All right, number one, it says Jalea makes a generalization about right numbers in scientific notation. Complete this statement. When you write a number greater than or equal to 1 in scientific notation, the exponent of the power of 10 would be what? Think about what they said, greater than or equal to 1 or less than 10.
It'll be. I said positive.
Good job. That would be positive. Because if it's greater than or equal to 1, that means it's a very large number. So it will be.
I think I put positive on the bottom and negative on the top.
All right, so the bottom said between 0 and 1. So that's when that whole number is a 0. So that would be a very small number, and that's when we get the negative exponent.
Miss Kitchens. For this part, I didn't know how to show my work on this.
Yeah, this one was just pretty much letting me know positive and negative. So yeah, it would have been good.
All right.
All right, so Cameron, make sure you don't confuse those wordings of greater than or equal to 1 or between 0 and 1. All right, number 2 said the total area of Kansas covered by water is about 5 times 10 to the second square miles. The total area of Alaska that is covered by water is about 9.5 times 10 to the fourth square miles. The total water area of Alaska is about how many times the total area of Kansas? Anyone like to tell us what you did?
Can you get a decimal for this? I'm just wondering. Cause I got it.
Yeah.
Now the key word said about, so they told you not to put it in the calculator.
I didn't.
It should have been an estimate, so you should have kind of got a hold on. But if you got a decimal, we'll take your decimal, we'll look at it. All right, nobody breaking up and tell us how to get started?
I wrote 5 times 500, and then I wrote 95000. Well, 4 zeros.
Should have been 3 zeros. Your 5 was your first place. So then
I did miss. You will mark it off until you get the even like equation. I'm not explaining.
Okay. All right, so Cammie got us started. The first thing you should have did was wrote them out into standard form. So the first one was 500, the second was 95,000. And then they asked us to compare. So you could have set it up as division. And then as we learned with patterns and division, only look at these whole numbers. So if you divide out 95 and 5, what will we get? 9 divided by 5 is? 9 divided by 5.
1.8.
1, and then it would have been 45 divided by 5. All we doing is 95 divided by 5.
19.
I'm trying to see who done forgot how to divide, and we divide by 5. Come on, wake up. 19. So then we eliminate those zeros that are the same. How many zeros are we left with?
1.
1. So that means it's about 190 times greater.
Miss Hitchens.
When
I was doing it, I did it like that, but I like divided, like I divided. Yeah, I did exactly what that did. So I said it was 95 greater. I thought 190 was the exact.
Yes, it should have been exact since both of them end in 0. So yeah, this one was exact William because of the zeros. Now if it would have been, now like yesterday we had numbers that was like 94, 570. So we would have had to estimate that to be 95. But since this one already came up with those zeros, yes, it should have been exact. Because 95 can be divided by 5. Good point. Any questions about number 2? All right, the third one we had last night. It says the population of the United States is about 3.2 times 10 to the 8. The population of the United States is about 80 times the population of Oregon. Write the population of Oregon in scientific notation. All right, somebody want to tell us how to get started?
I will.
Go ahead.
So it says the population of the United States is about 3.2 times 10.8. So I read that in standard form. It was 32 million.
Check your spaces when you said 32 million or is it 320 million?
32 million. Wait. 6, 7, 8.
Because the 2 would be the first place, and then we'll need 7 zeros.
All
So
right.
that's why I was telling others, if you want to do your shifts and your hops to actually see how many to go and put in, do it that way. But if not, definitely make sure we count that one place behind that delta.
All right.
All right, so I'm with you. Write it in standard form. So we should have got 320 million. And then they said it's about 80 times the population of Oregon. So we want to figure out Oregon. So would that be multiplying or would it be dividing?
Dividing.
Good job. That is dividing. I think that's Mercedes. So then if we divide that by 80, the same process, I'm only looking at those whole numbers. What's 32 divided by 8?
4.
Good job. Eliminate zeros, that's the same. And how many are left?
6.
Good job. So we should have ended up with the population for Oregon to be 4 million. Oh, and then they said write it in scientific notation. So if we got 4 million, what would that be in scientific notation?
4 times 10 to the 6th power.
Good job. Since it didn't have any numbers behind the 4, we would count all those zeros. Good job. Any questions about homework on last night? Okay. Today we're going to continue looking at scientific notation, and so we're going to dive deeper into adding, subtracting, and multiplying and dividing. I do hope you got your math notebook. We're going to start with a few notes on how we add and subtract with scientific notation. I'm going to give you about 3 to 5 minutes to go ahead and add that to your math notebook. All right, you may still be writing, and that's fine. I'm gonna go ahead and review it. It says to add and subtract with scientific notation. The first thing tells us to make sure we write both with the same power of 10. Shifting left adds to the exponent, and shifting right subtracts from the exponent. So we have to get them with the same power of 10. The second step tells us we are going to then add or subtract that decimal value, meaning the front part of that times 10. And then it told us the exponent will remain the same. And then last but not least, we got to check and make sure that it's written in scientific notation. And what's one way to make sure it's written in scientific notation?
Check it to see if it's the same answer you got.
Double checking that we got one number in front of that decimal. So after we do our calculations, we still gotta do that final step and make sure it's just one. Mercedes, Armani, Cammy, what these cameras at? Jakiriana, Makir, come on now. All right, and then last but not least, it told us if I just cannot remember these steps to change both to what?
Standard form.
Good job. So if you just cannot remember the process, change it to standard form. Is anyone still getting anything? Okie dokie. All right, an example of what that's gonna look like. So we have 950,000 plus 4.6 times 10 to the 7. 950,000 plus 4.6 times 10 to the 7. We're going to change the first one to scientific notation. So where would the decimal go?
It would go
Behind the
behind
9.
Yeah, so that would be 9.5 and what power of 10?
5.
5.
5. All right. That second step, what does that second step tell us we're going to do next?
Add and subtract the decimal value.
Good job. So now we're on. Let's go back to that first step because I think that first step told us we had to get the same power of 10, correct?
Yes.
All right. So let's look at this. We got a 5 and we got a 7. Which one you want to keep?
The 5.
The 5. All right. So that means the second one, we need to change that to a 5 as well. I believe your notes told us if we shift to the right, shift left, we're going to add to the exponent. And if we shift right, we're going to subtract from the exponent, correct?
Yeah.
Yes.
All right, so it gets from 5 to 7, we're going to shift 2 to the right. So now we have 460 times 10 to the 5th. 460 times 10 to the 5th. So we have to get them with the same power of 10. So just remember, go right, subtract, go left, we're going to add to it. So now that we have the same power of 10, Mercedes told us we're going to add those decimal values. So now we have 9.5 plus 460. Line it up to what we used to. 460. 9 is a 1 digit. 9.5. What we end up with?
469.5.
Good job. 469.5. That next step told us what about that power of 10?
What did you say again, Ms. Kitchen?
That next step told us what would happen with that power of 10.
It should remain the same.
Good job. So that will be 469.5 times 10 to the. And then that last step told us to check and make sure what?
It's written scientific notation.
All right, looking at this number, 469. Would you say that's in scientific notation?
No.
All right, it's not. So which direction are we going to have to shift?
Left.
Good job. So we're going to shift left until we get 1 digit. How many times do we have to move?
2.
Twice.
2. So then we will add 2 to that exponent to get what as the exponent?
7.
Good job. So this answer would be 4.6695 times 10 to the 7.
Miss Kitchens,
Yes, sir.
I have a question with this.
Go ahead.
Will the other decimal, at the end eventually will the other decimals equal each other? We started with 5, we used 5, and we're back to 7. So will that happen every time it doesn't work out?
Yes, and I'm glad that you mentioned that, William. With adding and subtracting, whichever your greatest exponent is, that's typically what the exponent of your answer is going to be.
All right.
I'm going to add that down here. Greatest exponent would typically be the answer. Good. And William, we also could have changed that 9.5 to the exponent of 7. So we would have just had to add 2 to the left, and that would have gave it 0.095 times 10 to the 7. But if we take that 0.095 and add it to 4.6, we would still get 4.695. Was I able to make that connection for you?
Yes.
All right, for this second example. For this example, we're gonna look into changing it to standard form. Some of us, we just gonna have to change it to standard form, and hopefully we can remember those calculations for adding and subtracting. So for 5.1 times 10 to the 12, all right, that's a big number. 51 and look like 12 zeros. And since it's subtraction, we're gonna go ahead and add that other number. And this will pretty much show you why they prefer that we don't add all those zeros and get confusing. But if you just need to, please do so. So in this instance, I'm gonna separate where I begin to see that first whole number of 3 in the bottom. So that means these other zeros are just gonna come right down. Just came down. So now we're gonna subtract with this portion. We should remember we're subtracting with 0, deduct 1, so 1,000 minus 1 will give us 999. 10 minus 3.
7.
9 minus 6.
3.
3.
All right, 9 came down, and then we're left with 50. Fill in those zeros, so the answer would be 50,000, 150, 993, 700, so on, so on, so on. And then after you do it in standard form, you still have to write it in scientific notation. So our decimal will go behind what digit?
5.
Okay. So now we have 5.09937
times 10 to the
To
8,000.
And that's 3, 6, 9, 12.
Oh, I forgot about those.
Did I count wrong? 3, 6.
13.
Did I count wrong?
Yeah, you kind of wrong with the 5.1. That's 13 numbers.
Yeah, that's 13.
It's supposed to be 5,001, 5,100,000,000,000.
Okay, so we need to cut off a 0. That's what you're saying, right?
Yes.
Okay, so we cut off that 0. These commas. All right, so that'll be 3, 6, 9, and we're back at 12. So that goes back to what I said earlier, that greatest exponent will pretty much be your solution. Thank you, William. All right, that's for those of us who just cannot remember those steps. But if we remember those steps, we're gonna go ahead and change it out. So this 6.3 would be 6.3 times 10 to the 9th. All right, we can keep the 12 as an exponent. So shift left 3 times. And I'm gonna add it at the bottom. So that'll be 5.1 times 10 to the 12. And then we'll take away 0.0063 times 10 to the 12. So after we get it with the same power of 10, we would compute with those, the decimals. So somebody take 5.1 and take away 0.063.
5.093.
5.0937. Gotta be. Okay. And then, of course, they told us that exponent will remain the same. So the 12 will remain the same, and then it's already one number in the front. It's already in scientific notation. We had an extra 0 up top. That's where we messed up at. Any questions about adding and subtracting with scientific notation?
I don't really get that much, but
What you not getting, Cammy?
the whole thing, like, I don't get it.
You got your notes in front of you with your steps?
Yes, ma'am.
Are you following the steps?
Yes, ma'am.
All right, we're gonna look at some more and make sure we follow those steps. Like the first step for the second one told us to get it with the same power of 10, correct? So if you look up top, we had different powers of 10. We had a 12 and we had a 9. So then we would need the same power of 10. In this instance, we kept the 12. So if we keep the 12, that means we had to move this second one to the left 3 times to get an exponent of 12. So when we went left 3 times, that's how we ended up with 0.0063. And now it has an exponent of 12. Once they get that same exponent, then we're able to calculate those operations. So that would have been just 5.1 and 0.063 that we subtracted, and that's what gave us 5.097. And then the lucky part is that the exponent is going to stay the same. All right, so with the next one, you might can catch on with it. All right, now we're finna look at some multiplying and divide. Different steps. So I'm gonna give you a few minutes to get them down. Multiplying and dividing is different than adding and subtracting, and it's easier actually. All right, you may still be writing, and that's fine, but I'm gonna go ahead and review it. So we're multiplying and dividing. Notice it didn't tell us to get it with the same power of 10, so you don't have to worry about shifting or none of that. We're gonna just go ahead and multiply and divide those decimal values. And then it tells us we're multiplying, we're gonna add those exponents back to those integer exponent rules we learned the first week. And then if we are dividing, we're gonna subtract those exponents. And then last but not least, check to make sure that it is in scientific notation. One number in the front, check for it. And then at the bottom, it reminds us again, if I can't remember these steps, to change to what form?
Standard form.
Standard form. So if you can't remember the steps, change it to standard form and perform the operations that way. All right, does everybody have it?
Yeah, ma'am.
Okay, okay.
Uh,
All right, two examples we're gonna look at for multiplying and dividing. So that first step told us we're just gonna multiply and divide those decimal values. So looking at the first one, we're gonna multiply 5.78. Somebody's connection is bad. All right, somebody got your handy dandy calculator? Go ahead and multiply those out.
$46.4712.
46.4712. Good job. The second step told us we're gonna add those exponents since we are multiplying. So what's 5 plus a -1?
40.
That would be 4. So then we're gonna write it the way we had it. We now have 46.4712 times 10 to the 4th. Is that in scientific notation?
No.
No. So if we shift 1 to get one digit in the front, what are we gonna do with that exponent?
Add 1 to it.
Good job.
No.
Any questions about multiplying with scientific notation? Multiply the decimal values, add the exponents, rewrite it, and check that it's in scientific notation. All right, for the second one, 3.6 times 10 to the 5th being divided by 2400. Once again, get them in the same form. So if we were to write 2400 in scientific notation, what would it be?
2.4 times 10 to the 3rd.
All right, 2.4 times 10 to the 3rd. Good job. All right, so that first step, we're going to divide these decimal values. So that'll be 3.6 being divided by 2.4.
1.5.
Okay, 1.5.
1.5.
Thank you, Maddie. And then since we are dividing, we're going to subtract those exponents. What's 5 minus
2.
2? So when we rewrite that, that'll be 1.5 times 10 to the 2nd. Is it in scientific notation?
Yes.
Yes. So that would be our answer. Any questions about what happens when we multiply and divide with scientific notation? Alrighty. Let's try this one. Notice this one deals with double operations or 2 steps. So looking at it, what would you say we would have to attempt to solve first?
The top.
Okay,
The numbers in parentheses.
when they all in parentheses, cause they scientific notation.
The 7.3 and 2.4.
Good job. So that we gotta look at first. All right, they are adding. The first step with adding told us to make sure what?
They gotta have the same.
Both are written with the same power of 10.
Good job. Same power of 10. I think Alexis started and then William finished. Which one we want to keep? The 6 or the 7?
That wasn't me.
The 7.
7, okay. So that means we need to shift this one over one time. So now we got 0.73 times 10 to the 7, and then 2.4 times 10 to the 7. So now we can add those decimal values. 0.73 plus 2.4.
$3.13.
All right, 3.13, and they told us that exponent will remain the same. Now we got 3.13 times 10 to the 7, which is being divided by 4 times 10 to the 4. Now, for division, what did the first step of division tell us to do?
Subtract exponents.
Okay, I think that's the second step, but we'll go ahead and do it. What's 7 minus 4?
3.
Okay. The first step told us to divide just that decimal value. So somebody go ahead and divide 3.13 divided by 4. 3.13 divided by 4.
0.7825.
0.78. I think that's what you said. All right, so now we got 0.78 times 10 to the 3rd. Is that in scientific notation?
Yes.
All right, sound like somebody said yes. Is it in scientific notation?
Yeah.
All right, go back to scientific notation. How many digits need to be in the front?
1.
Is 0 considered a digit?
No.
Okay, so that means we need to shift.
Yes. No.
So we're going to take one from that exponent. So now we got 7.825 times 10 to what power?
The second.
Good job.
2.
Good. 2. Did we lose everybody?
Going back to, I think Monday or so, when we first started scientific notation, with this, with multiplying and dividing, can you not use a small number as it?
Okay, now remember, Mercedes, and I'm gonna put it up here. A number like that isn't in scientific notation, so we can have a 0 in the front. But when we put it in scientific notation, we get rid of all those zeros.
Oh, okay.
So just remember, if it got the 0, it's in standard form. So you'll still have to change to scientific notation. Good question. Any other questions? All right, I know it probably seemed like a lot, but I hope you took your notes. Use those notes tonight as you're working those 3 problems and just try your best. That's all I expect you to do, try. And I hope you all have a great Wednesday.